Hi, in this video, we will be tackling exponents and radicals. They look intimidating, but once you know the rules, they're actually quite logical. The general form of an exponent is x to the power a, where x is the base and a is the power. The power tells us how many times the base is multiplied. Here are the basic rules of exponents, which we'll be applying in the SAT math questions. The first property is when the bases are equal and we are multiplying the exponents, we add the powers. Again, when the bases are same and we are dividing the exponents, we subtract the powers. When we have x to the power a whole to the power b, then we multiply the powers where we get a times b. And when the power is negative, we do the reciprocal of the base to get rid of the negative sign. Also, sometimes there could be questions where the absence and presence of parentheses would lead to different answers. Suppose if we have 2 to the power 3 whole to the power 2, that would be 2 to the power 6 by the third property of exponents. But if we have 2 to the power 3 to the power 2, that would be 2 to the power 9, because here we have continuation of power and both are not same. Also, if we have p times x to the power a, that won't be same as px whole to the power a. Suppose if we have 2 times 10 to the power 6, that is not same as 2 times 10 whole to the power 6, which would be 2 to the power 6 times 10 to the power 6. Also, anything to the power 0 would be equal to 1. The general form of a radical is nth root of x, where again x is the base and nth root is the radical. Nth root of x can also be written as x to the power 1 over n. For example, if we have fifth root of 8, we can rewrite it as 8 to the power 1 over 5. Now, when there is a difficult question on radicals where you see a negative power and also some fraction, so the first thing we need to do is get rid of the negative sign. So x to the power minus 2 over 3 can be written as 1 over x. So do the reciprocal to remove the negative sign in the power. Next, focus on the denominator. So the denominator is 3 here. That means it is third root. So this would be third root of 1 over x whole square. And we can simplify further to get the final output, which is cube root of 1 over x square. Now, here are some tips to solve questions on exponents. So if you have two exponents where the bases are same, suppose we have x to the power a equals x to the power b, that means a is equal to b. Similarly, if the bases are different, but the powers are same, so we have x to the power a equals y to the power a, then x and y must be equal. We can also plug in values in some exponents questions. Suppose you have x to the power 2 by 3 times x to the power some minus 4 by 6. So instead of solving, you could also plug in and verify for the output in the options. If you remember squares like 1 square, which is 1, 2 square, 4, 3 square, 9, thereon, and also cubes like 1, 27, 8, it will be easy for us to solve the exponents questions. And the rules which we have learned from left to right, you can also apply the same rules from right to left. Suppose if we have x to the power ab, we can also write it as x to the power a whole to the power b. And whenever there is a negative sign in the power, please be careful. Good luck.